Hey there, welcome back. So in the last video we saw the bottom view of binary tree. So in this video I'll cover the top view of binary tree, okay? And I'll take the same example as I've taken for the bottom view. So let me write the same example here as well. That is, okay. So 1, 2, 4 and 5, 3, 6, 7 and here 8 and 9. Okay, fine. So here the concept and the logic remains the same as for the bottom view. The only difference in this top view is, instead of pushing the every node in particular level, so let me draw that level as well. So the line, okay, this was like vertical line. So this was 0 and okay, so this was 0 and this was -1, this was -2 and this is 1, this is 2. Okay, so again here -1, 0, so this also comes here. I mean, let me properly write this as well. Okay, this also will come here. Okay, 9, something like that. Okay, so this was the vertical line, the for each nodes. Okay, so rather than pushing the node of every node of a vertical line into our map, we will push only the first node in that particular line. Okay, so here the output for this top view should be ideally the let me write the output here: 4, okay, 2, 1, 3 and 7. So this is the output of this top view of binary tree. Okay, so here what we will do here is, like, we will only push the line the node into particular line only if that line is empty. That means since we are using the map here, we will check kind of the condition check here would be, if that map of line is equals to end of that map, then only we'll push it, or else we'll not push it. So like that we will get only the top view of this given tree. Okay, so let's do the dry run same like we did for the bottom view. So now what we need is, as again I just put a briefly here, so we need a map here. What a map, as again already explained, map of int comma int, this is to store the line number and here the node value. Okay, so again and also now, since we are going to do the level order traversal, I would need the need queue of pair of node and the line with which it is associated. So okay, so we will push here the node and here the line number with which that is associated. Okay, so let's initially let's do the so initially I will push the into the queue the root value. The root value here is 1. Okay, and the line number is also line number is 0. Okay, so that is the thing we'll push initially into the queue. Now we'll do the traversal until queue becomes empty. So first what we'll do, we'll take the front part of the queue. So that is this 1 and 0, and here node value is 1 and the line number is 0. So and also I'll draw the map here. Since it is just 5 lines, I will just take a map of this -2, -1, 0, 1 and 2. Okay, so now the line number is 0, and so what the first condition check is, what the check should be for top view is, here the line number is 0, right? So here what we check is, if the map, this is map, right? So if map of 0 is empty only will push value into this map or else not. So here map of 0 is empty, so what we do is we'll push this one value to that map. Okay, now we check for the left and right child of 1. Left and right, yes there is, so we'll push the left and right. So here the map would become like this would be popped out. Okay, so now the map would become the left child of 1 is 2, and since we are going in the left direction, the line will be decreased by 1, and also there is a right child, so that is 3. So since we are going in the right direction, that will be line will be incremented by 1, so it becomes like this now. Okay, fine. Now this is the front part of our queue. So here the node value is 2 and line number is -1. So again now we will check the if the map of -1 is empty or not. Yes, it is empty, so we'll push 2 here, and now check for the left and right child of the root node 2. Okay, there is a 4 and 5, so what we'll do, we'll push that values into our queue. So here 2 and -1 will be this would be popped out. So here the now queue looks like this, that is 3 and 1. Now the left child of the 2, so left child of 2 is 4, and okay, and the line number would be decremented by 1, so that is -2. Okay, and now the right child of 2, right child of 2 here is a 5. Okay, so we will push that into queue. So right child is 5 and we are going in the right direction, so line number will be incremented by 1, so -1 plus 1 would be 0. So this is how it will be. Okay, so that is the child of the root node 2. So now again the front part would be the 3 and 1, so the node value is 3 and line number is 1. Okay, so we check again if map of 1 is empty or not. It is empty. Okay, so what we do is we push into our map. Okay, and this would be popped up, and check for the left and right child of the root node 3. Is there a left and right child? Yes, there is 6 and 7, so we'll push that into our queue. Okay, so now the queue becomes like this, that is 4 minus 2, and this 5 and 0 would be like that. And now we'll push the left child of the root node 3. Left child is 6. Okay, so here 6 and the line number was 1, so we are going in the left direction, so it should be decremented by 1, so it becomes the 0. Okay, and right child is 7. So since we are going in the right direction, so line number would be incremented by 1, so it becomes 2. Okay, so now the queue is like this. So now the front part of the queue is this, the node value is 4 and line number is -2. We check again if there is a value in this -2 in the map, so there is none. So what we do, we push into this map, so that is 4. Okay, fine. So and this would be popped out, and check for again left and right child of the root node 4. Is there a left and right child? So there is none, so we will not push anything to the queue part. Okay, so now the queue would be like this, that is queue would be 5 0 and 6 0 and 7 2. Okay, it will be like this. Now the front part front value is 5 and line number is 0. So now we'll check if the value at the 0 MP of 0, map of 0 is empty or not. We see here already there is occupied, that is 1 is there, so we'll not push this into the map. Okay, fine. So now we check for the left and right child of root node 5. We check there is a there is left child 8 and right child 9, so we should push that into our queue. So this is how this queue looks like after this, that is this 6 and 0 would be like this, and 7 and 2 would be like this, and root node left child of 5 is 8, and since we are going in the left direction, so it should be decremented by 1, so 0 minus 1 minus 1. Okay, and the right direction right child is 9, so we are going in the right direction, so again increment line number by 1. Okay, so now it becomes the 1. Okay, fine. Now the front part is 6. Okay, and so the current node value is 6 and the line number is 0. Okay, again check is there a value for the 0 line in the map. Okay, there is one, so we'll not push that. Again check for the left and right child of 6. There is none, so we'll not push any value into the map, so this would be popped out. So now the queue looks like this, that is 7 2 8 minus 1, 9 and 1. Okay, so this is how the queue looks now. The front part is value, node value is 7 and the level is 2. Okay, check if the for the line number 2 is there a value in a map. Okay, there is a none, so what we'll do, we will push that 7 into our map. Okay, so fine, that would be popped off. And now check for the left and right child of root node 7. Is there a left and right child for root node 7? So there is nothing, so we'll not push anything. So what then the queue looks like this, that is 8 minus 1 and then 9 1. Okay, fine. So now the front value of the queue is 8 and line number is minus 1. Check for the line number minus 1, is there a value in a map. Okay, we check for minus 1, there is a 2, so we'll not push that into map. And check for the left and right child of root node 8, there is none, so we'll not do anything, so that would be popped up. And then the queue is like this, 9 and 1. Okay, now the front value is 9 and line number is 1. Check for if there is a value for 1 in the map. So there is already 3, so we'll not push that into a map. And check for the left and right child of root node 9, is there anything? So there is nothing, so this would be popped out. And now the queue becomes empty and the traversal stops here. Okay, finally this would be our map. So when we print this, the values that would be getting is 4 2 1 3 7. Okay, so now let's check what the output which we mentioned in the earlier part. So that is 4 2 1 3 7. Okay, so which is exactly what we got. So this is the dry run and the way we should the way this bottom view top view traversal happens to get the answer. Okay, so now quickly let's turn to the code part and execute the same thing I have explained here. Okay, so just a second. So here we go, I have created the file topview.cpp. so in this we'll try to execute the code for this top view of a binary tree. Okay, so let me import the headers as usual. So that is I will input output stream, and I would need the vector, the same like we did for bottom view. Okay, so here again I would need the map, and I would need queue. Okay, and also utility to create a pair. Okay, that is utility, fine, and then namespace. Okay, so quickly I'll create the data type for this node. So val, and then pointers to point to left and right child of it respectively. So okay, and then I would write the function for the top view. Okay, so here input would be the root node. Okay, and then let's create one array to store our answer. Okay, and then the base check, if root is null, okay, we return this empty answer array. Okay, and then we would need one map to store the line number and its associated value. So let's name this as mp. So let me name this as mp, and then q to do the level order traversal. Okay, so this would be pair of this node and the line with which it is associated. Okay, so initially what we'll do, we will push the root node. So that is let's push the root node, root, and the line number is 0. So and then traverse till this queue becomes empty. Okay, so now we will take the front value of queue and pop that out. Okay, pop it out, and then take the root node by accessing the first element of a pair, and then line number like this, id dot second of a pair. Okay, now here the core check that we would be doing is if, okay, what I would do is I'll just check find that line is empty or not. So the check that how we will do is like this. Okay, the check I would do is I will try to find that line number, that is mp dot find of line is equals to mp dot end. Then only we'll know that okay, there is none value at that particular line. So then we will push that node value. Okay, so let me write that part. Okay, simple. So I will write like this: if mp dot find is equals to okay mp dot end, then we'll know there is nothing at that line. So I will push this node value. Okay, that is this one. Okay, or else not. Okay, and now check for its left and right child. If there are any, we'll push those values into our queue. Okay, so saying if temp to left push into our queue. Okay, so here the left child, then temp to left, and also we are going in the left direction, so we'll decrement the line number by 1. Okay, so like this. Okay, and check the same for right child, that is temp to right child is there, we will push that right child and increment the line number by 1. Okay, yeah, so this is the traversal of a tree. So once this traversal is done, yeah, we will have the answer required for us in our map. So finally what we'll do, we will iterate that map and push that values in the map to our array, that is like this. Okay, answer dot push back it dot second. Okay, so this is what so this should be for. Okay, yeah, so this is what this is how we will push the values from map to our answer array, and finally we will return that answer. So this would be having our required answer. Yeah, so that was the function for the top view of a binary tree. I mean, now let's write the function to create a node. Okay, so name this as a new node, and the input will be the value that this node will be having, and then quickly create the memory required for this node. Okay, so that is, so this will write struct node star and malloc to allocate the memory, and that is size of struct node. Okay, fine. So this is the we created. Okay, now we will put the value for this. Okay, temp to var is value, and temp to left would be null. We'll make the left and right pointers pointing to null. Okay, for now, so like this, and return this temp. Okay, so this is the function to create a new node. Now we'll create the main and create the same structure that we have seen in the explanation, and see if the output is matching to our explanation or not. Okay, so quickly I will write the structure of a tree, that is struct node root new node 1. Okay, and the root to left was new node 2, and root to right was new node 3, and root to left was 4, and then root to left to right was 5, and then root to left to right to left is 6, it is 6, and then root to right is 7. Okay, here it's not 6, it is 8. Okay, yeah. And now root to right to left is 6, and then last one, root to left to right is 9. Finally we have created the structure we wanted, and then we'll store the result of the top view function into answer array by passing the root node, and then finally we will print the top view of our required binary tree. Okay, so and then traverse that answer array and print the value at each index. Okay, so write for loop here and traverse till its end and print value at each index. Okay, and now let's run this and see if the output is matching to our explanation or not. Okay, again here I forgot to give space here. Okay, and now let's execute. Yeah, if you see, the output that we got is 42137, which is exactly we got while we were explaining or making a dry run of the given binary tree. Okay, yeah, so this is it for this video. Stay tuned for more coming videos. Thank you.